Okay, we're going to do some more examples of implicit differentiation, and we'll also talk about what it actually means. So we want to find dy dx, find the derivative of x to the fourth plus sine of y equals x cubed y squared. So we'll start with the left-hand side. We'll take the derivative of x to the fourth, which is 4x cubed. What am I thinking? And then the derivative of sine of y will be cosine of y, and then we need to multiply by dy dx. And then on the right-hand side, we're going to have to do the product rule because we have x cubed times y squared. So we leave x cubed alone, and we take the derivative of y squared, which will be 2y dy dx, plus then we take the derivative of x cubed, which is 3x squared, and leave the y squared alone. Okay, so I'm going to leave the left-hand side alone here. And I'm just rewriting this with the 2's out in front. Now we want to get all the dy dx stuff on one side and everything else on the other. So I'm going to put the dy dx terms on the left-hand side. So I'm going to subtract this term over to here, and I'm going to subtract this term over to here. So that will give us cosine of y dy dx minus 2x cubed y dy dx equals 3x squared y squared minus 4x cubed. So I'll factor out the dy dx. And divide both sides by this term. So our final answer will be dy dx equals 3x squared y squared minus 4x cubed over cosine of y minus 2x cubed y. Now you might be thinking, what does that jumble of terms mean? And remember that the derivative is the slope of the tangent line at any point. Now this equation, this relation, we can graph it, and you can see that this is the graph of it right here. Now it's not a function, it doesn't pass the vertical line test, but it still may be something that you're studying. And we can pick any point that's on the graph, okay, and these might be difficult to find, but for example right here, this would be the point 0, pi. So we could ask you to find the equation of the line tangent to, this equation at 0, pi. And we'd have to give you the x and the y, because if you noticed, there were actually 2 points when x equaled 0, 0 pi and 0, 0. So to get the derivative, this would be your point, but to get the slope, you would plug 0 in for x and pi in for y, and you would get the slope. So here it would actually be 0, and the equation of the line would just be y equals pi, but that's how you would do it in general. Okay, let's do some more implicit differentiation. We have xy equals cotangent of xy, so we're going to take the derivative of xy using the product rule. We'll leave x alone, then the derivative of y is dy dx, plus, now we'll take the derivative of x, which is just 1, and we'll leave y alone. Okay, now we're going to take the derivative of cotangent of x. So the derivative of cotangent is negative cosecant squared, so we get negative cosecant squared of xy. And now we need to multiply by the whole thing by the derivative of xy because of the chain rule, right? That wasn't just cotangent of x, it was cotangent of xy. Well, we've already taken the derivative of xy. We know it's x dy dx plus y. Okay, so my first step on the left-hand side, I'm just going to, that 1 is not necessary, so I'll just write that as y. And here I need to distribute negative cosecant squared of xy to both terms. So I'll write it as negative x cosecant squared of xy dy dx, then minus y cosecant squared of xy. Okay, again we need to put the dy dx terms on one side and the other, so I'll add this one over and subtract the y over. That'll give us x dy dx plus x cosecant squared of xy dy dx equals negative y cosecant squared of xy minus y. In my last, two steps, we got to pull out that dy dx, so we'll have dy dx times x plus x cosecant squared of xy equals this stuff. And then we're going to divide both sides by that term. So our final answer will be dy dx equals negative cosecant squared of xy minus y all over x plus x cosecant squared of xy. Okay, we've got one more here that we're going to do. We have x cubed equals 2x minus y over x plus 3y. So on the left hand side it's not too bad, the derivative's 3x squared. On the right hand side we have to do the quotient rule since this is a quotient. So low d high will be 2 minus dy dx minus high d low will be 1 plus 3 dy dx all over the low squared. Now we've got a lot of simplifying in algebra we need to do here. The first thing we're going to do just to make it a little bit simpler is multiply both sides by x plus 3y squared, this denominator, so that we clear out the denominator on the right hand side. So this gives us 3x squared times x plus 3y squared equals, and on the right hand side we need to FOIL each of these terms. So we're going to FOIL these out. So 2x minus x dy dx plus 6y minus 3y dy dx. Okay, and next we need to FOIL these two terms. We also have this negative 1 kind of out in front, so we're going to multiply each term by a negative 1 as we do it. So first we get 2x, it'll be a negative 2x. Then we get 6x dy dx, it'll be a negative 6x dy dx. And then we have a negative y, so that'll be plus y. And the last terms will be a negative 3y dy dx, so it'll be a plus 3y dy dx. Okay, and you'll notice this isn't probably the most pleasant problem you've ever done, but there are a few things that cancel out, right, or that can be simplified. So this minus 3y dy dx cancels out with this plus 3y dy dx. And let's see what else we can simplify. So we're going to leave this side alone. And on the right hand side, well, we have a 2x here and a minus 2x, so those actually cancel out. So here we have a negative x dy dx and a minus 6x dy dx, so we can make that a minus 7x dy dx. And so we did that and that. And then we have a 6y plus y, so we get plus 7y. So now you'll see it's not too bad. We're going to subtract 7y from both sides. So 3x squared minus 7y. And our last step, we just need to divide both sides by a negative 7x. So our final answer will have dy dx equals 3x squared x plus 3y squared minus 7y all over negative 7x. Okay, so I'm sure that wasn't fun just to sit and watch, but see if you can recreate those steps by yourself. And the best advice I can give you for implicit differentiation is to take your time and to make sure you're using all of the, the derivative rules we've learned so far correctly.